hi there. Thanks for showing up for your learning. As someone who wants to learn to graph quadratics fluently, I salute you. This is a fantastic skill. You're going to encounter so many quadratics in mathematics, and they describe so many natural phenomena that being able to work with these in your mind, visualize them quickly given either standard form, factored form, or vertex form, this is a really cool skill to develop, and you're going to enjoy having it. So on the sheets, we have standard, factored, and vertex form quadratics that we can work with. All right? And that's cool because we're going to want to be able to work with all three. And for these ones, I like working with numbers that are between plus and minus 10, and maybe with like plus and minus 5 for my A value. So I roll a 10-sided die for my A value. If it happens to be bigger than 5, I'll subtract 5 from it. That's a positive number. If it's less than 5, that's a negative number. And then for B and C, I'm going to use numbers between negative 10 and 10. So I roll a 20-sided die. If it's 10 or less, then that's negative. And if it's 11 or more, I subtract 10 from it as positive. So let's go. We're going to start with factored form, and I'll show you how to work with these. So we have negative 3 here. 15 is 5, and that's plus. And 10 is negative 10. Like that. I could also do 0 if I wanted. But I can choose negative 10 for this one. All right. So now I want to be able to very quickly visualize this quadratic. Y is equal to negative 3 multiplied by x plus 5 multiplied by x minus 10. And I recognize that the roots are taking these values and flipping them. That gives you the roots. So negative 5, 0, and 10, 0 are the roots. So let's say that's negative 5, 0, and this is 10, 0. All right. And then this quadratic opens downwards. So it's going to look something like this. And it's going to be very, very tall. Much taller than what that looks like. So I'm going to have to actually change the scale of my grid, which is fine. Change the scale. Okay. Next, let's go ahead and figure out how to find the y-intercept, because that's simpler. The y-intercept is going to be this point. I expect it to be positive based on my visualization. I mean, this is a quadratic opening downwards. I know that its roots are at negative 5, 0, and 10, 0. So that's what it looks like. And then, so if it opens downwards, I know that the y-intercept is up here somewhere at the x value 0, and who knows what the y value is? Let's find out. Because we know that the x value is 0, we can substitute that in and find the y value very easily. 0 plus 5 is 5, and 0 minus 10 is minus 10. So I just put in 0 for these x's and then evaluate. It's very straightforward. So this gives me plus 150. So this, oh, no, not there. This is the point 0, 150 is the y-intercept. It's huge, it's so tall. Well, we haven't even found the vertex yet. So let's go. How do we find the vertex? Well, I know that the vertex will lie along this line here, which is the average distance, like the center between the two roots. And so I can take the average of minus 5 and 10. So that's the average of minus 5 and 10. That happens to be 5 on 2, or 2.5. Work with whichever one you're more comfortable with. For me, it's that one. And then we just input that into the quadratic. So we're going to have y is equal to minus 3 multiplied by 2.5 plus 5 times 2.5 minus 10. Okay, so carry on. Y is equal to minus 3 times 7.5 times negative 7.5. I said I was more comfortable with fractions, didn't I? Oh well. I am. So that would be, but here, I'll do it this way because probably you're going to do it with decimals. So 7.5 squared. Okay, so 7.5. We got 7, we got 5, we got 7, we got 5. This is 49, but with 2 zeros. This is 350, and then this one is 25. So this is 75 squared gives us there 5625, and then we just need to put the decimal place in the correct place. So it's 556.25. Then we're going to multiply that by, but it's negative, okay, because one of them is negative. So we then multiply that by -3. So this is y equals 3 times this, which happens to be there. Get 168.75. So we have graphed this thing, and we have a fantastic sketch of it. We could also grab a symmetrical point from our y-intercept, and we know that that's 2.5 here. So this will be right at 5, and so that will be the point 5, 150. And then, you guessed it, we can check this in Desmos. So we just go ahead and type it in, -3 multiplied by x plus 5 multiplied by x minus 10. And then we're going to say, well, we need to change our view here. So we need it to see all the way up to, let's say, 200. And then that looks pretty similar to what we have over there, doesn't it? 168.75, good. We have this point here, 0, 150, and 5, 150, cool. And then we've got that, and we definitely have that. So we're very satisfied with our sketch. Okay. Good. So that's working with factored form. Let's get a fresh copy of this before we move on. All right. Now, how do we work with vertex form? Same idea for the numbers. Build yourself some random numbers. I like working with, oh, I closed it. Oh, I'm not happy about that. Numbers like this. There. Roll. Okay, so we are working with 5 here. It's very open upwards, like that. That 12 is plus 2. And that 15 is plus 5. So how do we graph the quadratic? Y is equal to 5 multiplied by x plus 2 all squared plus 5. Well, first of all, I can recognize the vertex from this form directly. So that's at -2, 5. So I can put that on right away. Here's -2, 5. So it's up there. And to make this more interesting, let's make this negative so that our quadratic now opens downwards. All right, so this quadratic is going to do this. If it opened upwards, I wouldn't have any roots, so I wouldn't be able to show you how to find the roots. Okay, let's go. So we've got that, and now we'll want to find our y-intercept next. Again, we can just set x equal to 0 and find the y-intercept very quickly. So this is y is equal to -5 multiplied by 0 plus 2 squared plus 5. 0 plus 2 is 2, 2 squared is 4, -5 times 4 is -20, so that's y is -20 plus 5, y equals -15. So this actually opens so sharply downwards that our sketch must simply be improved. So it's very go down, very go down. something like that. So this is the point 0, minus 15. This is the point 2, 5, but the 2 is negative. And then we would also have a point over here, negative 4, 15. Now last, we want to find these roots, the x-intercepts. So that's going to be a little trick that I'll show you with here. Y is equal to negative 5 x plus 2 squared plus 5. Okay, so to find the roots here, we have two options. One is to expand this to standard form and then use quadratic formula. The other one is simply to set y equal to 0 and solve for x. I'm going to show you this method first, then I'm going to show you a quadratic formula method. And I encourage you to use both because sometimes one is easier than the other. So if I set y equals 0, I get this. 0 equals negative 5 times x plus 2 squared plus 5. Subtract 5 from both sides. Why am I subtracting 5 from both sides? I want to take away the armor that's around x. I notice that there's something inside brackets here being done to x that's very difficult to dig out. There's this exponent. We're going to dig that out a little later. There's multiplication. That's not bad. But then there's this addition or subtraction. That's the easiest to move. So the first thing that I'm going to do is subtract 5 from both sides to move that. Then I'm going to go ahead and divide both sides by negative 5 because I'd like to cancel this away. So then that gives me 1 is equal to x plus 2 squared. Now we're going to go ahead and take the square root of both sides. So that will be the square root of 1 is equal to the square root of that. But then we have to remember, well, that could be plus or minus. So we have plus or minus 1 is equal to x plus 2 because we've taken the square root of a square, so that's gone. That's our inverse operation for removing the square. So plus or minus 1 is equal to x plus 2. Now subtract 2 from both sides and you'll get negative 2 plus or minus 1 is equal to x. Well, that means x is equal to, if it's plus, negative 2 plus 1 is negative 1, or if it's minus, then that would be minus 3. And these are the two roots. Turns out this is a factorable quadratic. Yeah, we're over here. So then our y-intercept here, we have roots are minus 1, 0, and minus 3, 0. Very cool. So we can label those. Talk about thinking about something and doing the wrong thing. Okay. And then you want to make these errors and catch them. That's a good sign. All right, and our y-intercept, we found that to be 0 minus 15. Cool. So now we have an excellent sketch of that. Now I told you we could also use a quadratic formula for this, and this is what it would look like. Y is equal to minus 5 times x plus 2 squared minus 5 plus 5. Now, in times where we can use quadratic formula, if factoring is available, factoring is also fine to use. And again, use both. Have the fluency to do whichever is easier. So first we expand this to standard form, and learning to do that with learn to do that in your head, and it's a good skill to have. You just take y is equal to minus 5 x plus 2 and square it. So we do this. Oh, and then we still have plus 5 here. And so we do that, and that's minus 5 times x squared plus 2x plus 2x plus 4 from doing all of our multiplications plus 5. And then we put it all together. Gives us this. That's after we combine these like terms and then distribute this in. Again, working with fluency means we're going to know which step to do at which point. And just do it. Now that we have that, we can go ahead and drop those into the quadratic formula. A is equal to minus 5, B is equal to minus 20, and C is equal to minus 15. And you just plug and chug your quadratic formula with that, or use factoring. Factoring here is very simple and straightforward. So another thing that we can do here, y is equal, so we are looking for solutions to the equation, not y, but 0 is equal to negative 5x squared minus 20x minus 15, because we're looking for these points where y equals 0 all along the x-axis. So that's why we set y to 0, and then we can find roots. Here I notice that I can divide both sides by negative 5, and it makes it very simple. 0 divided by negative 5 is still 0. X squared is x squared plus 4x plus 3. We're going to multiply to 3 and add to 4. Those numbers are 3 and 1. And this gives us the roots. X equals minus 3 or minus 1. Much easier than quadratic formula. Cool. All right, last one. Let's look at working with standard form quadratics. So we're going to go ahead and get ourselves a new copy of this as well. And let's go. We want to roll.